Hey everyone, it's Andrea. We're going to go ahead and start with this week with the Refelt et al. 2007. With this article, they talk about relational frame theory. And relational frame theory is it views perspective taking as a generalized operant behavior based upon a history of reinforcement for relational responding. So if you want to know more about relational frame theory, you can look into Hayes 2001 has a book on relational frame theory that kind of gives you a little more in-depth description of what it is. But a basic definition is ideally that you're able to derive different responses without contacting direct reinforcement. So you're able to learn many different skills of complex variety, typically verbal skills, and by not necessarily contacting the reinforcement or being directly trained those skills, you're going to emerge or derive skills without direct training. Perspective taking. Perspective taking is a deficit that's common in children and with individuals who have autism. Perspective taking is a skill that we typically want to work with when teaching individuals with autism. Some of the research on perspective taking, or most of the research on perspective taking, has traditionally been conducted in cognitive behavior research. And so there's what's called theory of mind, and the idea is that, based on that research, that children don't develop this theory of mind or perspective taking until around the ages of 5 or 6. So ideally, if let's say we have two children in a room, and one person puts their doll in a basket and leaves the room, and the other person puts that doll in a box, and then they come back in the room, the person will most likely think that they're going to look in the box for the doll and not looking in the basket because they don't have that perspective of the other person not knowing where the doll was moved to. So the purpose of this current article was to determine if children with autism would perform differently from their same-aged, typically developing peers, to determine if performance improved with reinforcement for responding relationally. So they had two different groups. They had a group with autism, 9 children in that group, and then they had 9 typically developing children in another. And so what they did is they taught perspective taking tasks using PowerPoint and Visual Basic. And you can see a visual in the article of how they had the computer screen set up for the participants to engage in these perspective taking tasks. So typically with perspective taking, also known as didactic framing, so if you're looking in relational frame theory and you see didactic framing, that just means perspective taking. But before they started the perspective taking procedure, they did want to get their adaptive skills. And so what they did is they conducted the Vineland adaptive behavior scale, and then they also conducted a social communication questionnaire. And basically these are two types of assessments that with the Vineland kind of identifies what skill levels you have and how do you compare to other children of what age level are you, I guess, with your skills. So then for the perspective taking procedure, what they did is they would have a question on the top of the screen, and then they would have to click the box for what would be the correct answer. And there was three relations that were evaluated. The first one is called a simple relation. So an example of a simple relation is I have a red brick, you have a red brick. What color brick do you have? What color brick do I have? So it's just very simple. I have this, what do I have? And then they trained reversed relations, which reverse relation is I have a red brick, you have a green brick. If I were you and you were me, which brick would I have and which brick would you have? And then it gets even trickier, and they go into double reversed relations, which is basically saying I'm sitting here in a blue chair and you're sitting there in a black chair. If I were you and you were me and I was here and you were there, where would I be and where would you be? So Overall, and you can look at the figures in the article, they show that most of the participants in both groups made more errors on the reversed relations than on the simple relations. But it wasn't necessarily the case that most error were made on the test trials for the double reversed relations. So basically, during this article, what we found out is that some of the findings could have been limited because of the small sample size and low statistical power. So typically when running statistical analyses, you want to have a large sample size, and the more individuals that you have in your sample, the stronger your statistical power is going to be. So that's why this is one of the limitations. And then also within group variability. So you want to make sure that your group is actually a representation of the population that you're serving. So you want to make sure that in the group you have a lot of variabilities that kind of accounts for all of the other extraneous variables that might be in that population. So they had mentioned that they didn't have a lot of variability specifically with the control group, and that may have masked further differences between the groups. But we did find some cool stuff during this, and one of the coolest is that there was a difference between the numbers of errors on the reversed versus the simple relations, and this difference was the most pronounced for the group of participants with autism. So basically this suggests that the test trials for the reverse relations required a more complex form of relational responding than test trials for the simple relations. So basically overall, the present study, the results suggest that perspective taking does not involve derived relational responding, as such a repertoire was required of the task. These students, this is also consistent with previous research that had been conducted. In order to further demonstrate a relational learning conceptualization of perspective taking, it is necessary to show that performance on the previous article, the Barnes-Holmes, that they had replicated, is indeed sensitive to reinforcement contingencies. And that the relations can be shaped through exposure to reinforcement. Another finding would suggest that perspective taking is a class of operant behavior. And so therefore they had a second experiment, and in the second experiment they wanted to further evaluate the notion that perspective taking may emerge via a history of reinforced relational responding. So what they did is they administered the same protocol that Barnes-Holmes had used in his research, and they administered this to two typically developing children. And the setting and the apparatus were identical to experiment 1. So they used PowerPoint and Visual Basic to create the questions, and then they had to click between the two answers. And then they trained simple relations and then tested for the emergence of other relations. So overall, the results from both experiments demonstrated that derived relational responding does play an evident role in perspective taking. And in order to further demonstrate the possibility that perspective taking is generalized operant behavior, future research should expose participants to the same protocol as was used in experiment 2, but they should also test for generalization to novel stimuli and novel tasks, particularly in the real-world situations that required the speaker to change his or her perspective with regards to references of a person. So then that brings us to our next article. We're going to be looking at Rehfeldt and Dixon, 2005. So typically when individuals who are verbally competent are taught how to make a series of conditional discriminations, new conditional discriminations may be demonstrated among those same stimuli in the absence of reinforcement, an outcome that is referred to as stimulus equivalence formation. So basically you teach one skill, we'll get into that more. This has been used a lot historically with visual comparisons and auditory visual comparisons, but it has not been used with gustatory comparisons. And gustatory just basically means taste. So before we go on, I'm going to explain stimulus equivalence just a little bit before we get into the article. But with stimulus equivalence, there are 3 different levels. The first one is you have A equals A, and that's reflexivity. And then the second one is you have A equals B, so therefore B equals A, and that's symmetry. And then down here, and the last one with transitivity, we have if A equals B, we train this, and then we can train, well, B equals C. So now we've trained this directly and provided reinforcement. We've trained this directly and provided reinforcement. So now we're going to test. Do they then automatically derive that C equals A without any direct training? And tons of research demonstrates that yes, if you are directly trained these 2 skills, this third one will come for free. So that's good to know when teaching individuals new skills, and stimulus equivalence is a great way to do that. So I have a little chart here, and you can see, so let's say we have the spelling of the word dog, so D-O-G. They have a picture of a dog, and then you have the vocal form of the word dog, so me saying dog. So let's say that I train that the sound dog matches the spelling of the dog, and then I train that the spelling of the dog equals the dog. Then for free, they're going to start, this skill will emerge for free without direct training. We'll just test. We don't provide any reinforcement. And they find out that this also matches the sound dog. So this is a very simple way to explain stimulus equivalence, and it can get a lot more tricky and a lot more in depth, but that's kind of a simple explanation. So back to the article. This investigation did want to extend the results of the Hayes et al. 1988 to adults with developmental disabilities using 3 stimulus classes. So they were serving as the first investigation of the formation of cross-model equivalence classes involving gustatory stimuli in individuals with developmental disabilities. So they were using stimuli that they could taste. And specifically, they made comparisons between the number of trials required for participants to master visual, and gustatory visual baseline conditional discriminations. So overall, accuracy on the equivalence test trials for visual, and gustatory visual equivalence relations, and maintenance over time of visual and gustatory visual equivalence relations maintained over time. So basically what they had is the visual and gustatory classes contained either tastes or pictures and their corresponding printed words, as well as socially acceptable Spanish words. So they taught the individuals how what the word was in English, what the word was in Spanish, and then matched it to the taste. I'm going to go ahead and pull up the article here. And so the reason that they chose these stimuli is because they were novel stimuli, they were novel sight words, and the children had expressed some interest in learning a different language, so that's why they chose Spanish. So the participants were 4 adults with intellectual disabilities, and they had 2 sets of 9 stimuli. Out of those 9 stimuli, it was 3, 3, and 3. So 3 of them were Spanish words, 3 of them were English words, and then 3 of them were the gustatory. And participants were instructed to choose one of the 3 comparison stimuli placed in front of them on the table after they were handed and had either looked at set 1 or tasted the sample stimuli. And the order of all of the training and test trials, as well as the positioning of the stimuli for each trial, had been determined prior to the experiment. And the reason that you usually want to look at the order of how something's being administered is that you can protect for side bias or protect for prompt dependency and stuff like that. So typically when you're doing conditional discriminations, if you always put the answer on the left side, they may not learn how to discriminate between the 2 pictures, but instead they're learning to always choose the one on the left. So you want to make sure that you mix it up and keep it random. Basically, 3 of the 4 participants required fewer training trials to acquire the gustatory visual baseline conditional discriminations than the visual baseline conditional discriminations, and that's consistent with the previous research that they found that Hayes et al. Had discovered in 1988. and previous comparisons of the acquisition of unimodal and cross-modal conditional discriminations. Sorry, I'm in the wrong spot on my notes. So in summary, what they found out was that all four participants with developmental disabilities were initially unable to make the accurate conditional discriminations, but then after the match to sample training, they were able to do so. And so that means that using stimulus equivalents to teach people with developmental disabilities to learn new words, pictures, or tastes provides caregivers with additional options for effective treatment and to better enhance the lives of the people they serve. So it's kind of nice to use stimulus equivalents because if you can get more skills, if they can learn more skills without you having to directly train each skill, it's like you're getting a lot of skills for free. And while stimulus equivalence at times appears daunting, or it might appear as if it's a lot of materials or really challenging, if you see A1, A2, A3, B1, B2, B3, C1, C2, C3. But once you kind of get a grasp of stimulus equivalence and you start to understand it more, it's actually kind of really cool and strongly recommended for a lot of the discrete trial programming. And if you want more information about stimulus equivalence, obviously it's in the articles, but then there are assessments and training protocols available that are directly geared towards stimulus equivalence that you could look up. So the next article we're going to look at is Sidman et al., 1985. And they basically discovered that, or they were talking about in the intro, that procedures for teaching subjects conditional discriminations may also generate equivalence relations, and sample stimuli may become equivalent to their corresponding comparison stimuli. And if they do, the three defining properties of equivalence relations, reflexivity, symmetry, and transitivity, which we previously talked about, will be demonstratable. So during this article, the subjects were pre-tested on conditional discrimination and oral naming procedures with familiar stimuli and for generalized identity matching with all letters that were to be used as experimental stimuli. And then the baseline for the equivalence test was established by teaching subjects the 5 groups of conditional discriminations denoted by solid arrows, and you can see that in Figure 2. And next, the existence of stimulus classes was evaluated by testing the subjects for each of the 20 groups of conditional discriminations denoted, and you can see those in Figure 3 by the broken arrows. And emergence of the conditional discriminations would demonstrate the existence of a 6-member classes, and others would demonstrate 5, 4, and 3-member classes, and symmetry of conditional relations. So finally, they also wanted to see oral naming of the stimuli. They tested for oral naming of the stimuli, and variations in the procedures for establishing baseline and in the method of alternating the teaching and testing phases were noted. So the subjects did sit before a 9 translucent touch-sensitive keys where stimuli were projected from the rear. That was the apparatus that they had used for the study. So first they started with the conditional discrimination. So can the individual discriminate between 2 different pictures, and if they responded with a correct answer, they were given either a penny or a token, and if they responded with an incorrect answer, they didn't receive reinforcement. And they could later exchange the pennies or tokens for something bigger like food later. So in baseline, the subjects were taught groups of baseline conditional discriminations, which are represented by the solid arrows in the figure. And then they did conditional discrimination tests. So this is where they're not directly training, they're just testing to see if these discriminations. So they had 27 trials of a group of 3 untrained relations, and you can see all these 3 groups in Figure 3. And they were inserted as probes among 45 baseline trials. The subjects did receive no chimes, pennies, or tokens on the probe trials. And in preparation for unreinforced probes, the baseline reinforcement probability for 2 subjects was gradually reduced to 0.2. In experiment 1, the subjects each learned groups of conditional discrimination separately, and then the 3 relations within a group being taught in a prescribed sequence and groups being combined only after subjects met the accuracy criterion at each step. And then in experiment 2, subjects were given the first 12 conditional discriminations all mixed together. So in the experiment 1, they had the conditional discriminations separated, and then in experiment 2, they mixed them all together. With no restrictions on the order that they were to be learned. And then the subjects were then tested for the 3-member ABC and DEF classes, which you can go to figure 1 and see that. And before those classes were linked together by teaching EC relations. The subjects in experiment 2 were tested for 3-stage relations in the context of a reduced baseline, which you can see in figure 1. And before learning the full baseline, they were tested for 3-stage relations in the context of a reduced baseline before learning the full baseline. 6-stage relations emerged without additional testing of the prerequisites. And so then in experiment 3, the baseline was enlarged progressively, starting with AB and AC. Subjects were taught conditional relations that were prerequisites for classes of gradually increasing size. And after each consecutive teaching step, they were tested for the appropriate stimulus class before learning the next set of relations. So therefore, they were successfully taught the baseline relations AB, AC, EC, DE, and DF, which you can see in figure 2, with tests for 3, 4, 5, and 6-member classes, respectively after successive teaching phases. So you can see that there's a lot of different classes, a lot of different relations coming out of this. So then after learning the baseline conditional discriminations AB and AC, the subjects were then tested for 3-stage relations, BC and CB, and then the baseline was then progressively enlarged so that one set of relations at a time and conditional discriminations that would demonstrate 4, 5, and 6-stage equivalents were probed successfully. So then if you look at table 4, you can see the sequence in which baseline conditional discriminations were taught and mixed with previously learned relations to form new baselines. And the tests were given with no reinforcement. Remember, during the test, you don't want to reinforce during that phase, immediately after the subjects had learned each baseline. Probe trials were presented in the context of the smallest baseline that would be required to derive the probed relations. So then after the 6-stage test, the existence of 6-member classes was verified by probing all remaining relations in the context of the full baseline. And then finally, at the end, they tested the oral naming. And stimulus class formation as an outcome of conditional discrimination training has now been carried well beyond the original demonstration of 3-member classes. So overall, 8 of the 11 subjects showed that the conditional relations they had learned were also equivalence relations. And the first indication was the emergence of the FB and BF conditional discriminations for which the prerequisites involved all sets of stimuli. Then in test after test, with no reinforcement being provided, the lower stage relations emerged with remarkable consistency, and subjects matched stimuli according to class memberships that the original teaching had established. So teaching 15 conditional discriminations, 5 groups of 3, had basically created 3 6-member stimulus classes, making the subjects capable of 60 new conditional discriminations that they had not been explicitly taught. So that's really cool. They taught 15 conditional discriminations, and then they got 60 for free. So if you think of when you're working with your kids, kids or adults, but typically if you're doing this kind of training, they might be a little younger. But when you're working with your kids, it's important to know and possibly utilize stimulus equivalents, because look at how many skills that you get for free instead of having to directly teach all of them. All right, so we're going to move on to our next article, and our next article is Sundberg et al., 1990. I'm going to go ahead and pull that up. So Sundberg et al. Talks about traumatic brain injury, and traumatic brain injury it can typically have long-term physical and verbal deficits, and treatment for this population does vary greatly, and a lot of the treatment does stem from cognitive research. And one of the difficulties with using treatment that stems from cognitive research is they don't have a very strong demonstration of experimental control. So we don't really know if their independent variable is what is actually creating the behavior change. So that's why we want to kind of look at this from a behavioral point of view, and using Skinner's analysis of verbal behavior to help individuals who have traumatic brain injury, particularly aphasia as a result of the traumatic brain injury, learn new verbal skills. So efforts to identify the effects of brain injury, So in addition, this research incorporates the finding from the growing body of literature on the application of Skinner's verbal behavior. Specifically, this article addressed four main questions. Which verbal operant will be acquired first? Will a response established under the man conditions occur under tact and interverbal conditions without direct training? And then will a response established under tact conditions occur under manned or interverbal conditions without direct training? And then the last thing they looked at was, will a response established under interverbal conditions occur under manned or tact conditions without direct training? So what they did is they had two men who both had been diagnosed with traumatic brain injury, and they both had received these injuries from motorcycle accidents. So wear a helmet if you have a motorcycle. That way, if you're in an accident, you won't get TBI. Both of the individuals also demonstrated signs of aphasia, and they had limited verbal skills. I think that they were able to echo, but they weren't, and sometimes they could say the name of the item, but they weren't able to tact it. They might be able to man for it, but not be able to tact it, or they might be able to echo it, but then not be able to tact that item. So in this experiment, they used 18 common objects that were divided into 6 sets. And they had 3 sets for each subject. So subject 1 consisted of a funnel, electrical tape, and a row of staples. And then set 2 for subject 1 was a plastic bag, a bottle brush, and a 3-pronged adapter. And set 3 consisted of an extension cord, a tire gauge, and a nutcracker. And then for subject 2, their set 1 was a box of dental floss, binoculars, and a crowbar. Set 2 was a staple remover, wire cutters, and a paper clip. And set 3 consisted of a nightlight, a lint brush, and a paint stirrer. So these items were chosen because they were familiar to the subjects, and they also had correct receptive and functional use behaviors, and so they were able to functionally use these tools. They weren't just randomly chosen items. And then with these, so since they had correct receptive use, they were able to point to the item when you asked them. If you said point to the binoculars, they could point to the binoculars. But then if you held it up and you said, what is this? They wouldn't be able to tact it. And if you had it and you said, oh, what do you want? They wouldn't be able to say, I want the binoculars. And then the same thing with the interverbal. If you held it up and you said, tell me something that's black, they wouldn't be able to respond with that interverbal by saying the binoculars are black. So they created response definitions for each individual, and it was recorded as correct if the subject's first response corresponded with the item that was being tested. So if they did, as long as they said the correct response, even if they said other things with it, that was still being scored as correct. So if they said, let's see, that's a binocular, then that would be scored as corrected versus incorrect. So the independent variables were specific training procedures, which are going to be described later. But basically, the procedures involve the use of contrived establishing operations, prompting, fading, and differential reinforcement. And in general, there were 9 dependent variables: the acquisition of tacks, mands, and interverbals for sets 1, 2, and 3. Specifically, dependent variables consisted of the percentage of correct responses during training and probe conditions, and the number of training trials required to meet the session termination criterion. So they had 2 types of reinforced probes in the study. One type was a first trial probe, in which the first trial of a training session constituted a probe. And the other type was a one trial generalization probe on the operants not targeted for intervention. And these generalization probes were conducted on all untrained operants prior to the training segment of a session. They did collect reliability for 20% of the sessions, and they did have the main liability agreement was 99%. And so then for each subject, the 9 items were randomly divided into 3 groups and assigned to one of the 3 training sets. And the 3 training sets were TAC training, MAN training, and interverbal training. And you can see how all of the items were set up for subject 1 and subject 2 in table 1. So then during baseline, they basically would have each of the conditions in baseline where they would probe. So they did a MAN probe, they did an interverbal probe, and then they would do TAC training. So the intervention, they had different phases for the intervention. And so for phase 1, each of the subject's 9 words were divided into 3 sets using the procedure previously described. And either a TAC, MAN, or interverbal training was given on each of the 3 sets. And so for subject 1, intervention began with TAC training only. Interverbal training was added after the 6th session, and then MAN training was added after the 12th session. For subject 2, he had stronger verbal behavior and easily handled a large number of trials, so all 3 conditions began simultaneously. With the TAC training, they would first do a test probe for each word, and correct responses were reinforced with praise, and incorrect responses initiated the start of the training procedure. And the procedure used for TAC training was essentially the same one that was used in Sundberg 1980 and 1987, with individuals who have intellectual disabilities. And stimulus control was transferred from echoic control to TAC control by the use of prompting, fading, and differential reinforcement. So basically, the experimenter would hold up the item and say, what is it? And if they had a response within 5 seconds and it was correct, they would provide reinforcement. But if there was no response within that 5 seconds, they would give an echoic prompt. So if I said, what is this? And I got no response, I would say binoculars. And then following a correct echoic response, the experimenter was represented with the original